Okay, good evening to everyone. See, in the today's class, I am going to present about the parasympathomimetic drugs. Okay, in the today's class, we are going to start about the parasympathomimetic drugs. See, before starting the parasympathomimetic drugs, see what are the important points to be focused. Okay, see structural activity relationship of acetylcholine. Okay, in the gate to 1998 they have asked. Okay, onium group, quaternary amine containing compounds. Next, classification of the drugs. Next, ring system of pilocarpine. Okay, that especially used in the case of glaucoma. Next, in the gate 1997, okay, 1998 they have asked about the pilocarpine. Next, synthesis of timolol. Okay, next is the synthesis of timolol. So this is about the different important points to be focused from the parasympathomimetic drugs. Okay na. See now here what are the different receptors that can be involved in the parasympathetic nervous system. Okay, action of acetylcholine. See, acetylcholine that will act on the exocrine glands. It will increases the secretion of exocrine gland by acting on the M2 receptor. Okay, along with that, acetylcholine that will act on the G80. Okay, through the M3 receptor. It will increases the tone, decreases the motility of the gut, and relieves the spasm and decreases the sphincter tone. So it might be responsible for the defecation. Okay na. Next, acetylcholine that will act on the stomach. Okay, by acting on the stomach through the M2 receptor, it will increases the HCl secretion. Next, acetylcholine that will act on the urinary system through M3 receptor, thereby it will increases the tone of detrusor muscle. Getting a next, acetylcholine that will act on the respiratory system through M3 receptor, it will increases the branchial smooth muscle contraction and secretion. Next, acetylcholine that will act on the eye through the M3 receptor. Okay, it will opens the trabecular meshwork around the canal of scream and increases the aqueous humor drainage. Hence, this drug should be used in the case of treatment of glaucoma condition. Okay na. Next, acetylcholine that will act on the cardiovascular system through M3 receptor. Okay, thereby it will decreases the heart rate, nothing but negative chronotropic effect, that is bradycardia. Okay, next, decreases the force of contraction, that is negative chronotropic inotropic effect. Okay, decreases the AV conduction, that is negative dromotropic effect. Finally, it will reduces the cardiac output. Acetylcholine that will act on the blood vessel. Okay, through M3 receptor, it will causes vasodilation, thereby reduces the blood pressure will be there. Okay na. Okay, so next, okay, next, what is the thing means, now we have seen the different actions of acetylcholine. Now what are the contraindications? So in what cases we can contraindicate the acetylcholine? Okay na. This thing indicates both indication and contraindication. This slide indicates both indication and contraindication. See, because of vasodilation, it will decreases the blood pressure, hence it should be contraindicated in hypotensive patient. Okay, it will increases acetylcholine by acting on the stomach, it will increases the HCl production, hence it should be contraindicated in peptic ulcer disease. Next, next, see, acetylcholine by acting on M3 receptor, it will causes branchial smooth muscle. Okay, contraction of branchial smooth muscle, hence it should be contraindicated. Okay, hence it should be contraindicated in case of asthmatic patient. Okay, getting a next, see, because of decreased cardiac output. Okay, because of decreased cardiac output, this drug also contraindicated in case of myocardial infarction. Okay, it is also contraindicated in case of myocardial infarction. Okay na? Okay. So next, see, this is a I, okay, that I that is containing, okay, I that is containing both alpha 1 and M3 receptor. See, alpha 1 receptor that is located on radial smooth muscle, okay, M3 receptor that is located on circular eye muscle, okay. This can be located on circular eye muscle. So this is about the muscarinic receptor, okay. Muscarinic M1, M2 and M5 receptors are there, okay. The secondary messenger is IP3 and tag. It will responsible for excitation. M2 and M4 receptors are there, okay. It will activate adenyl cyclase, inhibit the release of cyclic AMP. The action, what kind of action it will do means it is responsible for the inhibition, okay. It is responsible for inhibition. Next, okay, next when comes to the drug classification, okay, now when comes to the drug classification here, see, cholinergic agonist drugs, also we can call it a cholinomimetic or parasympathomimetic drugs, okay. Example is cholinergic agonist, example is choline esters. What are the example of choline esters? Acetylcholine, okay, methacholine, carbachol and betacholine. Next, alkaloids drugs are there, okay. Alkaloids drugs, under this one muscarine will be there, okay na, okay. Muscarine drug, next one is pilocarpine, next one is arecoline. Mnemonic is map, okay. Map nothing but muscarinic, A nothing but arecoline, P nothing but pilocarpine. Next, anticholinesterase drugs, okay. Anticholinesterase drugs, that is reversible. Example is carbamates. Reversible example is carbamate. What are the example of this drug is physostigmine, neostigmine, pyridostigmine, edrophonium, rivastigmine, donepezil and galantamine. Getting a next, acridine, that is tacrine will be there. Next, and under the anticholinesterase, irreversible drugs, okay. Under the irreversible carbamates, that is carbaryl and propoxyl will be there, along with organophosphate drugs will be there, okay. Along with that organophosphate drugs, that is difluoxoethiothiophate, melathiano, diazinon, tabono, sarin and soman, okay na. So this is about the different types of the drugs, that is cholinomimetic drug classification, okay na. Next, very important point, okay na, important point they have asked in the Gpat. See, acetylcholine is a drug, okay na. Acetylcholine is a drug, acetylcholine is a drug that can be bound to the anionic site and esteric site, okay na. Carbamate also bound to the anionic site and esteric site, but edrophonium that will bounce only to the anionic site, okay. Next, organophosphate is there that will bounce to the only esteric site. Ecothiophyte that can bound to the both anionic and esteric sites. Now, important, see what is the importance of this one means acetylcholine, okay. Acetylcholine is a drug, see, acetylcholine is a drug that will bound to the both anionic and esteric site. So the duration of action, okay, the duration of action is milliseconds. Next, carbamates, see, carbamate that will bound to the anionic and esteric site. So the carbamates that is having the duration of action is minutes, okay na. Next, edrophonium drug is there that will bound to the anionic site, okay. The duration of action is 8 to 10 minutes. Next, organophosphate is a drug that will bound covalently to the esteric site, okay. Esteric site it will bound, the duration of action is hours, okay na. So this is about the metabolism of different drugs, okay. This is about the metabolism of different drugs. Next, muscarinic receptors are there, okay. Organophosphates will be there, so organophosphate that will go and bound to the muscarinic receptors. See, if we are giving the organophosphate, what will happens, okay, it will increases the acetylcholine, means organophosphate that will inhibit the choline esterase enzyme. By inhibiting this enzyme, what it will do is it will increases the acetylcholine level. Okay, it will increases the acetylcholine. Next, atropine is a antagonist. Okay, atropine is a antagonistic drug. Okay na? Next, see, next one is pilocarpine drug will be there. Okay na? Next drug is pilocarpine. Here we are discussing the medicinal chemistry point of view. See, pilocarpine is a drug. Pilocarpine, it is a drug. Okay, see, P letter indicates pupil constriction. P letter indicates pupil constriction. ILO nothing but imidazole will be there. Okay, ILO nothing but imidazole. CAR nothing but carboxylate. Okay, carboxylate nucleus will be there. Okay, next, P nothing but pressure. Okay, pressure in eye. PINE nothing but pressure in eye, nothing but glaucoma condition. Okay, for the treatment of glaucoma we can use the pilocarpine drug. Okay na? Next comes to the, okay, when next comes to the, what is the basic nucleus that can be identified in the pilocarpine? That is tetrahydrofuran. So this is a tetrahydrofuran is there. Next one is imidazole. Okay, this is the imidazole. Tetrahydrofuran and imidazole, two nucleus will be there. Okay na? Two nucleus will be there. So this is the pilocarpine. Next, see, next one is acetylcholine. See, acetylcholine drug is there. See, acetylcholine that is contain COCH3 group. Okay na? COCH3. It contains which functional group? That is COCH3 functional group is there. See, this functional group can be immediately metabolized. Can be immediately metabolized. Getting a, see, because of immediately metabolism, the drug having short duration of action. The drug is having short duration of action. The drug is having short duration of action. So what we people are doing? So because of methyl group, okay, because of methyl group, the drug is, there is a large delta positive charge is there on carbonyl carbon atom. Okay, large delta positive charge is there. Because of large delta positive charge, it will undergoes hydrolysis readily. It will undergoes hydrolysis readily. So hence we need to replace this isosteric replacement of methyl group with amine group. Isosteric replacement of methyl group with amine group should be there. Getting a, so what will happen if we people are replacing the, methyl group with amine group? What will happen? There is a resistance to the metabolism. The drug is resistant to the metabolism. Now we can discuss those drugs. See, this is the acetylcholine. Okay na? This is the structure of acetylcholine. How we have given the name? Acetyl group is there. Okay, acetyl group. So this is the choline moiety. So this is the acetyl group. So that is the choline moiety. That's why the name acetylcholine is there. Okay na? That's why the name of the drug is acetylcholine. Next, see, next drug is carbachol. See, carbachol, here what we have done to the acetylcholine means, see, the methyl group of acetylcholine that can be replaced with amine group in order to resist the metabolism. Hence what we people have got? Now we have got the carbachol structure. Okay, now this is the structure. If you are replacing methyl group with NH2 group, then we will get the carbachol as a basic nucleus. Next, methacholine drug is there. Okay, next methacholine drug is there. Next, bethanical. See, methacholine nothing but to the acetylcholine, if we people have added methyl group, then we people will call as a methacholine drug. Next, in bethanical, what is there? We have added amine group along with methyl group. Both amine group along with methyl group is there, hence bethonical. See, this is a alpha carbon, so this is a beta carbon. Beta carbon we have substituted methyl group, hence we can call it a bethonical. Okay na? Hence we can call it a bethonical drug. Next, so acetylcholine. So this is the structure of acetylcholine. See how the IUPAC name. See, when it comes to the acetylcholine structure, what are the functional groups are there here? In the acetylcholine, what are the functional groups are there? In the acetylcholine, ammonium group is there. Okay, ammonium group along with ester group. Okay, along with ester. See, among ammonium and ester group, which functional group will get more priority? Nothing but ammonium group will get more priority. Okay na? See, ammonium group will get more priority, hence we need to give more priority to the ammonium compound, that is ethane 2 carbon containing ethane aminium amine. See, amine plus IUM nothing but it indicates positive charge on the nitrogen. If we are combining this one, then aminium it will be. E letter can be replaced with, okay, E letter is replaced, so aminium drug, that is so ethane aminium is there. Ethane nothing but 2 carbon containing, aminium nothing but nitrogen that is containing positive charge. See, on the N, okay, on the nitrogen what is there? 3 methyl group is there. 1, 2 and 3. 3 methyl group is there, hence N, trimethyl. 3 methyl group is there. Along with that acetoxy, acetyl group along with oxy, hence we can call it acetoxy. Okay na? So this is the structure of acetylcholine. See, numbering is like this, we need to give. This is the major functional group. Okay, ammonium is major functional group 1 and 2. Okay, only 2 carbon is there, hence ethanaminium. Next comes to the carbocal. See, carbocal, it contains carbonyl group. Carbocal, that is containing carbonyl group along with choline moiety. So this is the choline moiety, hence we can call it a carbocal structure. Okay na? Here see, the IUPAC name is same. It is having anion, so it is having anion, so we need to write at the last. Along with that ethanaminium, ethane, okay, aminium, 2 carbon containing ethane aminium is there. So N, trimethyl group is there. Next, what is there? Amino carbonyl. Amino nothing but this functional group. Carbonyl is this one. Next, oxy. Okay, that is at second position. The entire substituent is there at second position. So this is about the carbocal. Next, methacholine. See, methacholine, that is containing methyl group. Okay, here methyl group is there. Along with methyl group, acetyl group is there. Acetyl group along with that choline moiety is there. Along with that choline moiety is there. So this is the structure of this one, methacholine. See here, what is there? Aminium. See, 3 carbon containing. 1, 2 and 3 carbons are there, hence it is propane. 3 carbon containing aminium. Okay, nitrogen, it is containing 3 methyl groups, hence we can call it N, trimethyl. Acetoxy, okay, acetyl group, oxy group, hence acetoxy. This is there at second position. Okay, this substituent is there at second position. So this is about the methacholine structure. Okay, now getting a next one is bethonical. Next drug is bethonical. See, bethonical, that is containing beta-methyl. Okay, bethonical is a drug that contains beta-methyl. ANE nothing but urethane moiety is there. Okay, what is that urethane moiety? Nothing but this. Okay, also we can call it a carbamate. Okay, see, urethane nothing but 2 carbon containing. Okay, 2 carbon containing. See, urine nothing but urea group along with ethane nothing but 2 carbon containing it is. See 1 and 2 carbon, hence we can call it a urethane moiety is there. Hence beta methyl, A nothing but urethane, col nothing but acetylcholine, sorry, col nothing but choline moiety is there. So this is about the bethonical drug structure. Okay, same IUPAC name is same, that is propan aminium. Okay, propan 1 aminium, N comma N comma N trimethyl. Okay, carbomoyl nothing but this group also we can call it a carbomoyl. Carbomoyl group, that is at second position. This is the numbering 3, so second position it is containing carbomoyl oxy group is there. So this is the bethonical. Next, see acetylcholine and carbachol. See both acetylcholine and carbachol that are non-selective drugs that will act at muscarinic, both nicotinic and muscarinic receptor. It will act at both nicotinic and muscarinic receptor. At the therapeutic doses, the effect of carbachol and acetylcholine are entirely due to the activation of muscarinic receptor. See at therapeutic doses it will purely activate the muscarinic receptor because more abundance of muscarinic receptor is there. Okay. Next, see as one of important of M3 receptor is action of M3 receptor is profound vasodilation. Okay, by increases in the synthesis and release of nitric oxide. By release of nitric oxide and increases the synthesis, it is shows the profound vasodilation. Okay, the vasodilation is life threatening. Okay, this hypotension can be avoided by preventing the directly entry of directly acting sympathomimetic agent into the circulatory system. Say acetylcholine and carbachol is there that will act on the muscarinic receptor. Okay, by acting on the muscarinic receptor, what it will cause is vasodilation, that is profound vasodilation. See, because of profound vasodilation, it is responsible for the life-threatening hypotension. So how we can avoid this vasodilation? Nothing but just by giving the drugs through skin. By giving the drugs through the skin, the hypotension can be avoided by giving the drugs through topical route of administration. Next, carbamates. When comes to the carbamate drugs are there. Okay, that is a physostigmine. Okay, next rivastigmine. Next one is neostigmine drug is there. Okay, neostigmine drug is there. Next one is pyridostigmine drug is there. Okay, next one is pyridostigmine. So this is about the different kinds of the drugs available here. Now we can discuss about the each drug. See carbamate. What is the carbamate group? Carbamate nothing but NHCOOR. Okay, NHCOOR group we can call it a carbamate. See in every drug NHCOOR group is there. That's why we can call it a carbamate drugs. That's why we can call it a carbamate drugs. Getting a next physostigmine drug is there. See physostigmine nothing but phenyl group is there. Okay, phenyl group. Iso nothing but what is that iso nothing but same. What is that same? 2 pyrrolidine nuclease is there. Okay, iso nothing but 2 same pyrrolidine nuclease is there, hence we can call it a physostigmine drug. When comes to the IUPAC name, okay, when comes to the IUPAC name, we can give the numbering like this. So the numbering is like this. So the numbering of the drug is like this. So what is the basic nucleus? It is a carbamate. So we need to write the carbamate, that is methyl carbamate. One side it is containing methyl group, hence we need to write the methyl carbamate. Next, what is their indole group is there. So this is we can call as a indole group. Okay na, indole group, that is 2,3B. Okay, 2,3 nothing but when we are separating number 1, 2 and 3 position will be there. So B bond that can be attached between these 2 pyrrolidine, hence we are writing 2,3 B letter here. Next, what is there? 1 position 1, 2, 3, 3A. Okay, 8, 8A. All these having hydrogens, hence hexahydropyrrole. Okay, hexahydropyrrole 2,3B indole, along with 1 position 3A position, 8th position. See 1 position 3A position, 8th position, it is contains What it contains? Methyl group. Hence we are writing the trimethyl. Next, reverse stigmate drug is there. Okay, na? Next drug is reverse stigmate. When comes to the reverse stigmate drug, see, it is also containing the carbamate only. Reverse stigmate, that is also containing carbamate nucleus only. See here, first we need to identify the functional group. See, functional group is always carbamate here. Just we need to start the numbering from the carbamate like this. After giving the numbering, again 2 carbon is there, we need to give the numbering. So first what we need to write? Carbamate we need to write. So this is the carbamate is a major functional group. So it is containing, see, nitrogen, that is containing ethyl and methyl. So as per the alphabet, E letter will come first, then M letter will come. So we need to write the E letter. Hence N ethyl, N methyl. Okay, that can be attached to the phenyl group. Okay, phenyl group is there. To this phenyl group, what is there? 2 carbon containing ethyl group is there. Ethyl group is there. Next, what is there? Dimethyl amino. See, 1 2. So dimethyl amino group is there. This entire substituent, that is, can be located at third place. The entire substitution that can be located at third place. So this is about the reverse stigmate drug. Next, neostigmine. See, neo nothing but what is the meaning of neo? Okay, na? See, neo nothing but this part we can call as a neo. Okay, this part we can call as a neostigmine. Like neopental. Neostigmine is that contain quaternary ammonium. See, because of quaternary ammonium, what is the functional group here? Ammonium is a functional group here. Hence what we people are doing? Because of ammonium group, we need to write benzene. See, ammonium that is attached to the benzene. Hence we are writing benzaminium. Okay, benzene. Okay, aminium is we are writing. On nitrogen, what is there? 3 methyl group is there. Okay, on nitrogen, what is there? 3 methyl group is there. Hence we people are writing N, N, N trimethyl. N, N trimethyl. Then what is there next? Oxy group. Oxy carbonyl group is there. Okay, N, N dimethyl. Okay, dimethyl amino group is here. Correct? Huh? I hope you people are getting the neostigmine structure and IUPAC name. So this is the numbering for this one. The numbering we need to give because highest priority functional group is ammonium group. So the numbering we need to start from there only. So this is a neopentyl group. See, 3 carbon, 1, 2, 3 carbon is there. Middle 1 carbon is there. Instead of carbon, what is there? Nitrogen is there. Isosteric replacement of carbon with nitrogen we will get the neostigmine structure. Next, pyridostigmine structure is there. See, pyridostigmine, it is a drug can be used in the treatment of myasthenia gravis. Okay, na? Pyridostigmine, it is a drug can be used in the treatment of myasthenia gravis. See, pyrido nothing but that is containing the pyridine. Pyrido nothing but it is a structure that contains the pyridine as a basic nucleus. Okay, na? Hence what we people are writing, see, pyridine, that nitrogen that is containing positive charge. Hence we need to write pyridinium. Okay, pyridine plus IUM. IUM, it indicates positive charge. Okay, next, what is there? Methyl group is there on pyridinium. Hence 1 methyl pyridinium is there. Next, at third position, numbering we need to give from the nitrogen 5 and 6. So this is the numbering. Once we have given the numbering, at third position, what is there? Substitutions are there. Okay, third position substitution, that is dimethyl. Okay, 2 methyl group is there. Hence dimethyl. What is there? Carbonyl. Carbonyl nothing but NHCO, NH2 group we can call as a carbonyl. Okay, next oxy group is there. Okay, next oxy group. Hence we can call it a pyridostigmine. So this is the structure of pyridostigmine drug that can be especially used in the treatment of myasthenia gravis. Next, hydrophonium drug is there. Okay, next drug is hydrophonium. See, hydrophonium nothing but it contains ethyl group. Okay, Dro nothing but hydroxy group is there, pH nothing but phenyl group is there, O-onium nothing but ammonium group is there. Okay na? Onium nothing but ammonium group is there. So this is about the different structures that can be identified in the hydrophonium. So it is a short, the drug is having short duration of action. It is act mainly at a neuromuscular junction. It is used to diagnose the myasthenia gravis, majorly used for the diagnosis of myasthenia. We can use the hydrophonium drug. Okay na? So numbering is like this. Numbering, it will starts from the ammonium containing group. Getting a now the IUPAC name. Okay, see IUPAC name, that is benj benj see benzenium will be there. Okay, benzenium will be there. Next, what it contains? 3 methyl group, N comma N comma N trimethyl. Okay, N comma N comma N trimethyl group is there, benzenium, along with 3 hydroxy group is there. Finally it is contains chloride. Finally it contains the chloride moiety. Okay na? So this is the hydrophonium structure. Next, donepezil drug is there. What is the donepezil? Nothing but it contains indinone drug is there. Okay, indane. So this is the indane. If it is containing ketone, we can call it a indinone drug. If it's contain ketone, we can call it a indinone. PE nothing but piperidine. Okay, piperidine is there. Hence PE. GIL nothing but benzyl. GIL nothing but benzyl nuclease is there. Okay na? So this is about the donepezil drug. Okay, this is about the donepezil. It contains indinone along with piperidine along with benzyl. So this is about the donepezil drug. Next, this drug majorly used for the therapeutic use in case of Alzheimer's disease. So majorly in the treatment of Alzheimer's disease, we can use the drug donepezil. When comes to the IUPAC name, first we can identify. Okay, first we can identify the functional group, that is ether group is there. Here ketone group is there. Ether and ketone group is there. So ketone group we need to give the more priority. Hence, okay, what we are writing, 2, 3. Numbering first we need to give like this. So numbering is like this. So this is the numbering of donepezil. After giving the numbering, what is there? 2, 3. See 2 position, 3 position, what it contains? Dihydro. Indene 1 position it is containing ketone. Okay, now 1 position it contains ketone. Next, what is there? 5, 6 dimethoxy. 5th position, 6th position it is containing dimethoxy. Next, what it contains? Methyl group is there. What is it contains? Methyl group along with piperidine. Next one is benzyl group is there. Next one is benzyl group is there. So this is about the donepezil drug. Okay, donepezil drug structure and its IUPAC name. Next, acetylcholine. Okay, next acetylcholine is there. See acetylcholine that will bound to the different parts in the receptor. See hydrophobic pocket, to this hydrophobic pocket what will bounce? Methyl group will bound. Okay, here one amino acid is there that contains amine group. To this amino acid, this 2 oxygen atom will go and bound. So it is 2 oxygen atom, it is forming the hydrogen bond. In Gpat they might be asked, hydrogen bond can be formed. This is a hydrophobic bond. Hydrophobic. So this is ionic bond. So here it is ionic bond. It is here 2 methyl group that will form hydrophobic bond. Okay, na, hydrophobic bond it will forms. So next one is 2 methyl group is there. 2 methyl group also that will forms hydrophobic bond only. Okay. Next, okay, next one is adverse effects of cholinergic. See adverse effect of cholinergic drugs, that is dumbbell. D nothing but diaphoresis, that is sweating. Okay. U nothing but urination will be there. Next M nothing but meiosis. Okay, pinpoint pupil will be there. Next B nothing but bradycardia. Another B nothing but bronchospasm. Next another B nothing but branchial secretion. Next E nothing but emesis. L nothing but lacrimation. L nothing but loose stool. Okay, so this is about the adverse effects of cholinergic drug. So this is about the adverse effect of cholinergic drugs. Next, what are the side effects of cholinergic drugs? Side effects of cholinergic drug. What are the side effects of cholinergic drug? That is mnemonic is SLUD. Okay, the mnemonic is SLUD. What is the meaning of that SLUD? Okay, S nothing but salivation will be there. L nothing but lacrimation, U nothing but urination, D nothing but digestion, another D nothing but defecation will be there. Okay, after this one, cholinergic side effects. Okay, sorry, anticholinergic side effects. So these are the anticholinergic side effects are there. So what are those anticholinergic side effects? See, in cholinergic increases salivation nothing but in anticholinergic decreases the salivation, that is dryness of mouth. Okay, decreased lacrimation nothing but blurred vision. Okay, decreased urination we can call as a urinary retention. Decreased digestion nothing but nothing will be there. Okay, decreased defecation nothing but constipation. So what are the side effects of anticholinergic drugs? Nothing but dryness of mouth, blurred vision, urinary retention and constipation. So this is about the drugs, cholinergic drugs, their IUPAC name. Okay, their IUPAC name of the drug. So with this, today's class is about to end. Getting a, if you people have any doubts regarding the class? Is there any doubts? Okay, with this we have closed the today's session, that is parasympathomimetic drugs. Okay na? Is there any doubts with respect to the class? Okay.